are talking about silver, we often think about material from coins or plates or jewelry. But the truth is, silver is more than that. Assalamualaikum and great day. I am Syafiqah Syazwani binti Jaffar from Biotechnology Research Institute, University Malaysia Sabah UMS. Today, I'm going to share with you my research project entitled Green Synthesis and Characterization of Silver Nanoparticles using Carrageenan. Cited from Visual Capitalist website, silver is widely used as a precious material, largely comes from industrial manipulation and other uses for jewelry making, physical investment, and silverware, which the application are continuously progressing since the Middle Ages era. Silver nanoparticles, on the other hand, is a nanometer-sized solid particles which has unique and improved properties compared to its bulk molecules, particularly in its high thermal and electrical conductivity, outstanding optical properties, as well as biological activities. According to the recent report, the global market of silver nanoparticles worth $1.69 billion in 2019 and expected to grow at an impressive CAGR of 14.4% in 2026. The demand for this precious metal is mainly dominated by the healthcare and life sciences sector, followed by clothing and textile, electronics, and food and beverages. Silver nanoparticles can be synthesized using physical, chemical, and biological routes. The physical routes such as laser and vapor condensation require high energy and often produce low yield, while the common chemical synthesis route using sodium borohydrate and trisodium citrate has many drawbacks, as the reactions usually are uneconomical, which the resulting products require stabilization before and after synthesis due to byproducts and high reactivity of the silver nanoparticle produced. Therefore, biological rules, also termed as green synthesis, are now the major focus. In green synthesis, biological molecules such as fungi and algae undergo extraction process to acquire the specific extract such as polysaccharides and proteins to act as the reducing agent. In this study, carrageenan is used as the reducing and stabilizing agent for formation of silver nanoparticles. Carrageenan is a negatively charged polysaccharide with a large number of hydroxyl and sulfate groups that can be utilized to facilitate reduction of silver ion via electrostatic interaction. But why carrageenan? Carrageenan is a compound derived from red seaweed, and Malaysia is the third largest seaweed carrageenan producer in the world, with the state of Sabah is the major contributor. Exploration of this abundant material would certainly bring significant socio-economic impact to our country. The problem statement that we want to address in this study are: first, negative environmental impact, high cost, and low stability of the silver nanoparticles produced through the conventional synthesis route, and second, limited studies on the application of carrageenan, major seaweed polysaccharide produced in Malaysia, as reducing agent to mediate green synthesis of silver nanoparticles. Therefore, the objective of this study are to synthesize silver nanoparticles using carrageenan and to characterize physicochemical properties of the resulting silver nanoparticles. The method involved is by a simple hydrothermal reaction of carrageenan solution with varying concentrations from 1 to 5 millimolar with 0.1 molar silver nitrate as the precursor. The resulting silver nanoparticles were further characterized for its optical and functional properties, morphological, elemental and structural analysis, topography, as well as crystallographic behavior using UV-Vis spectrometer, Fourier transform infrared spectroscopy (FTIR), scanning electron microscope (SEM), energy dispersive X-ray (EDX), transmission electron microscope (TEM), atomic force microscopy (AFM), and also X-ray diffraction (XRD). So, the formation of silver nanoparticles is confirmed based on its color changes from colorless to brown solution. The stability of the silver nanoparticles produced will be monitored using UV-Vis analysis for 1 month, and the most stable silver nanoparticle synthesized using 2.5 millimolar carrageenan solution was observed by the surface plasmon resonance (SPR) absorption peak at 420 nanometer. Next, the functional group present in the silver nanoparticles can be observed by FTIR spectra, corresponds to the OH, CH stretching, COSO3, and SO sulfate group located in the region 3200 until 3400, 2900, 1300 until 1400, and 1000 wave number respectively. Furthermore, EDX spectra shows the high composition of elemental silver 85.87 weight% with other elements present such as carbon, sulfur, and oxygen consistent with the FTIR result. Next, XRD analysis of the silver nanoparticles produced represents crystalline phase of pure silver with 4 major breaks peaks shown along with the crystal size of the produced silver nanoparticles ranging from 18 to 50 nanometer. On the other hand, the morphology and structure of the synthesized silver nanoparticles can be seen through the SEM, TEM, and AFM images, which shows that the nanoparticles are in spherical size embedded in the surface. Meanwhile, particle size distribution of the silver nanoparticles analyzed from TEM images shows broad particle size distribution ranging from 20 to 200 nanometer in size, suggesting potential agglomeration of the individual particles. This may be due to uneven distribution during the reaction, which can be further improved with varying reaction time or temperature. As a conclusion, Carrageenan, which is abundant in Malaysia, especially in Sabah, can be used as environmentally benign, easily accessible, and effective reducing material in the green synthesis of silver nanoparticles, which can be further utilized for its various functionality. This is the reference that I use for this presentation. And I would like to acknowledge my co-researchers from BRI UMS, UIA, and TUAT Japan for their contribution, as well as UMS, Ministry of Higher Education, and JPA for the financial support. With that, that's the end of my presentation, and thank you for your attention.